Yeah. How is Lab 0 setup going through? Like, are you guys able to um, basically go through the environment setup, utilize the office hours, settle down a little bit, know the organization of the course, how to seek help, etc.? Like, is it getting better? Okay, so again, just to make sure everyone, because also we might have new joiners to the course, we have office hours daily from 10:30 to 2:30. In addition to the lab sessions which are running this week. So make sure also you go to your own specific lab session if you have questions. You don't have to be on the lab session if you don't have any question. If you are done with the lab, it's only for offering help, right? Submitting the lab is exactly as instructed in the lab document, and you don't have to be during the lab session to submit that. If the autograder shows a check mark on GitHub, does it mean we pass? Jack, well, it means you pass whatever tests you already submitted to your code. But for example, in Lab 0, you are asked to add at least one additional test case, right? If you didn't add an additional test case, but you pass the ones that we give you, which are like 2, you will still get the green check mark, right? But this doesn't mean you get the full mark because you didn't add a test case. So the green check mark for GitHub basically means you pass whatever tests you have already submitted to your repo, which at the very least includes the ones we give you, but you should also add yours as instructed in the lab document. Okay, I guess there was a question related to the error we got last time, which is when me and I, that's also something I wanted to share with you because some of you might already have that. So what I found is not really related to the min.gw. It was mainly related to the way Eclipse accepts the studio.h as an input. So in some compilers, we add them as like those larger than and smaller than brackets. In Eclipse, well, you need to do them in double quotes, right? So this is how it solves the problem. But in fact, Eclipse has, especially in Windows, I don't know in Mac, because Mac again is a Unix based. The main problem is not really an Eclipse problem, it's mainly a Windows problem. They have like Windows console has a problem with printf and scanf, mainly because the way things are being buffered, right? So I would say the good thing is that for all our test cases, you are really clearly instructed not to print anything on the console, because this also delays the submission to the GitHub. So you are not required to print anything. There is no scanf or printf in all the labs. We are using our own unit testing methodology to provide input to your program. So you shouldn't have any problem with Eclipse regarding this, right? But if you want to exercise, for example, what we have been through in the previous lectures using printfs and scanfs, there are workarounds in Eclipse. They are not very neat. So if you don't want to confuse yourself, just use online GDB for those kind of examples if you would like, right? Brian, yes, you shouldn't be adding printfs in your lab at all. If you already added, please modify this and resubmit. Yeah. When we add our own test, do we add it to this? Yeah, Tyler, it's already yes, you have to. Yeah, correct. I guess Lab 0 doesn't already state that. Like you have to add your function definition in the CU suite. I might revisit this, but I believe Lab 0 should have clear instruction about that. Okay. So another thing is, again, if you are still facing problems with the lab environment setup, please utilize the remaining time for office hours and lab sessions. I will also make sure tomorrow after lecture, I would stay for some time. Well, maybe I can do this today as well. If you have a significant problem that you seek help from TAs, but you weren't able to get like the support you need, let's after this lecture, I will stay for maybe 30 minutes or so to answer any questions that you weren't able to get help from the TAs for those questions. Okay, but other than this, please utilize the TA of ours because this helps us stay organized. Okay. Yes, Peter, that's correct. This is related to the flushing the buffer using flush standard out. Yeah, this can be a workaround. So I am supposed to write include story to H now. ADN, yeah, that's correct. If you are using Eclipse for printfs, that's correct. Okay, so let's jump into the lecture to go through some of the examples. Let me see. Okay, so we went through few examples last lecture. Again, some kind of hands-on. We try things out, but we want to do this time. Well, I just want to show the problem itself. What we want to do, if you remember what we have done last time, first of all, reading 10 integers from the user and just add all them up without any condition. We used for loop for that, right? And then the second example, we built on top of this by saying, well, right now I don't want to add all the numbers. I only want to add the odd ones. And we added the if condition that handles this, right? In this example, we really want to change the condition a little bit to be a little bit more complex by saying I want to keep reading inputs from the user. So I don't have a specific number. The user can really input anything. Well, how many? It's both. It can basically, it's, well, this would work, I believe, if you have a space or like quotes, right? So both should work. Okay. Okay, going back to what I was saying is, previously we read a specific number of inputs from the user, which has been 10, right? In this example, we want to keep reading from the user until the user decides not to input anything more, which for us here we included that the user, if it inputs one, if the user inputs one, then really we stop. Otherwise, we keep reading. And then once the user inputs one, we just output the sum of all the numbers. Okay, and the sum shouldn't include the first one. Okay, which means like the basically the one that the user inputs. So we use one as a mark that, well, I'm done with inputting my integers. Okay, how to do this? So I will switch sharing and go back to online GDB. This is what we had last time. Okay, let me just pull this a little bit down, make it a little bit smaller. Okay, I'm not sure if I'm still around. I guess I'm still around on the desktop, right? So you guys still hear me, right? Because I guess my tablet disconnected. This is why but well, you still hear me, correct?
Yes,
Can
we
you
can
please
hear you.
confirm in the chat? Yeah, we can hear you. Okay, thank you. Okay. Yeah, my tablet is back as well. So this is what we had last time. This was, well, the last state of the program we have been writing in the last lecture. Quickly going through this, we have been printing please input 10 things, and then we modified the print a little bit to like basically print please input like the first number, the second number, etc. And then we only add it if it's an odd number, right? The question now is how to modify this to do what we want to do in the third example, which is keep reading until, well, I enlarge this a little bit again, until the user inputs a specific number, which is in this case 1, right? Previously, we had a for loop because we had a specific number of iterations, right? We want to read 10 numbers, right? Right now, well, we don't know exactly the number we want to read. Sometimes the user will just input one number and then one. Sometimes it might just input one directly. Sometimes it might input 1,000 numbers and then one, right? So the number is not predefined. But we still want to keep reading from the input, right? So we still need a loop, but maybe 4 is not the suitable one for that, correct? Right? So what kind of loop we should do? Well, the general rule, maybe you know this from Python, is that if you have an iteration that is based on a condition, what kind of loop you should be using? Can someone just write on the chat? Use a while loop. Exactly, Arthur. Thank you. So what we can do now, in fact, we can still use for. So something also for you to know is that really for and while they don't provide any additional expression to each other. Like, for example, whatever while can do, for can exactly do. So they don't provide additional functionality. So they behave exactly the same way, but they are more convenient in that sense, right? So what I want to say is that we can still really use for, but it makes more sense. It's more logical if we use while loop, because here we have our iterations based on a condition, correct? So what I'm going to modify right now, well, I'm just deleting this. Then say, right now it will not just be please input 10 because it's not 10. So please input integers to add to get their sum, and input 1 to exit, right? So this is what we want the user to do. And then I have a while loop. So the syntax is just write while, and then here is my condition, and then I open my code block bracket, right? So what should be the condition? What do you think? If I just say true, Arthur, that means it's always true, correct? So this is an infinite loop, right? I can still really write true and then do the exit condition inside, but what if I want to do the basic thing, which is just write the condition inside, right? I'm asking Liam and Olu and others for this exact purpose thing, and like most of you are really saying this. If I is not equal 1, but really is the condition based on I? Remember that I is our counter for the iterations, right? Right. So we want our condition to be input 1 to be related to the input from the user, not for our counter, right? Our input from the user previously, what we have done is we stored it in X, right? So yes, so until X is not equal 1, correct? Then I do something. What do I do? First of all, I need to read the user. And then, well, similar to what we have done before, I'm reading an int, and then I'm placing this in X, right? And then, well, after reading it, I should add this to the sum, right? Right now, I don't have any conditions, so I will just say sum equals sum plus X. And then at the end, maybe I would just want to print the sum similar to what we have done yesterday. So I would say printf sum equal, and then this should be also an int, and then I'll just put the sum here, right? So let's see if this works as intended or if we have problems, right? So we'll discuss that question, but let's quickly through the logic again. What I'm doing right now is I'm initializing my input that I'm taking from the user to 0, initializing my sum. Well, right now I'm not using I at all, right? So maybe I don't need it now because there is no counter, in fact, for the loop. My condition is based on X instead. So I would say if X is not equal 1, because this is the condition that I want to exit in, read something from the user, and then add X to the sum, correct? So each time I'm reading something, well, if it's not 1, I will add it and then do the sum. Does this make sense to you? Do you have any comment or question on this? I see some questions here, so let me look into the chat. Question from Hakam: why is I not given an initial value? Well, I just deleted I because I'm not using it at all. Hakam, Ahmed, what if the user wants to add 1 but it exits? So the definition of the problem, if you remember the very first lecture we talked about in computer engineering, we said the very first step is to define your problem, right? And then write an algorithm to include this. The definition of the problem is to say 1 means exit. It's not allowed as an input to be added to the sum to your problem. This is basically by definition, right? If you want to add 1, you should use your encoder to be a different number, like something like -1, for example, right? So it's up to you. But right now we are not using 1 as a possible input. We are just using it as our exit code, right? Question: does scanf always read the previous printf line? For example, would 2 printf lines? So scanf has no connection at all. Matthew, this is your question. This is an important point. These are 2 separate functions, 2 separate calls. It has nothing to do at all. Scanf has nothing to do at all with printf, right? Printf is printing something on the screen, done. Scanf is expecting some sort of input. In fact, I can have scanf without a printf at all, right? But in this sense, it will not be very usable for the user because the user will not even know that he is expected or she is expected to provide some input, right? But there is no connection between these two at all, right? Isaac, will the program exit the loop right after the scan input 1, or it will finish iteration of the loop first? That's one of the good questions related to this logic. What happens right now? When do I exit the loop? Let's think about it. So each time I execute something, like let's say, for example, we are at the very first initial iteration, x is 0, so it's not equal 1. The user inputs something. Assume at this point the user inputs 1, right? Just for sake of explanation. Then, well, here I don't have any exit logic, so I will continue my loop, right? And then sum is equal sum plus x, but x is initially, let's say the user inputted 1, so I will add the 1, so sum will equal 1. Go to the next iteration. Then if that's the case, well, x is equal 1, so I just, the condition is not satisfied, and I finish, right? So let's rerun this to see it. I guess it's better to visualize it. Yes, if I do that, please input integers to get their sum and input 1 to exit. So right now I'm executing this line. Assume I just inputted 1, okay? What would happen is that, as I was saying, well, I inputted 1, I added 1 to 0, so sum is 1. I exit the loop because in the next iteration, x is equal 1, and then I just print the sum. Is this the logic we want to achieve? Is that correct, based on the problem definition? What do you think? What did the problem say? If you read the slides, you'll find that the problem is saying, well, if you input 1, you should not be adding 1 to the sum, right? So that means we need to change something in this logic, because right now the 1 is added, right? So what can I do then? What do you think? No, the sum should not include 1, correct? So what? Add an if statement. Well, that's a possible way. So something I can do is to say, well, if right now I add some condition, if x is equal 1, which might be possible inside this loop, or maybe not equal 1, that's an easier condition, I just do the sum. Otherwise, I don't update my sum. And in this case, well, if the user inputted 1 even in the very first iteration, it will not be added to the sum. Good. So if I just say stop, well, it's already stopped, so I'll just run. Let's say I input 1. Now the sum is still 0 because, well, it's not added, right? Even if I run it, then I say, well, I input 2 first, and then I input 5, and then I input 1. The sum is 7, so the 1 is still not added. Good. So we kind of achieved the logic we are looking for. Does this make sense? So let's see questions. For the second printf print, well, it's printf, not print yash, right? So there is no print in it. It has to be printf. Do we need the scan before the while so that it reads the number first? Emma, that's a good question. And this is one of the things we are going to discuss. There are multiple ways of really writing exactly the same logic, okay? So what Emma is saying is, can we modify it such that, well, instead of really just checking it for the first time, I read a number first, and then based on this, I either enter the loop or not, right? Because let's see if I want to rewrite it to really put the scanf before, such that I read something before even checking the loop. In this case, if the user inputs 1, I will even not go inside the loop, right? So I might not just need this logic now, right? And that's a good point. So that's basically another way of writing it in a simplified way. I don't need the if condition. Why I don't need the if condition in this case? Because if I read it before the loop, when I hit this line in execution, if x was 1, then, well, I will not enter the loop, and then I will not add and then finish. But there is one problem with this logic, right? What is the problem with this logic? So it solves the problem of inputting 1 and we need to put some condition inside, but it adds another problem. What do you think? Well, it might be an infinite loop if the first X wasn't 1, correct? But generally, you are only reading once, right? It only one scan the first, exactly, yeah, right? So here I have the scanf outside the loop, so I only read once, right? So that's not correct because I want to keep reading, right? So something I can modify is I can also add another scanf here after the sum, right? So I would say, well, read the very first number. Based on this, you will go to the loop and then do the sum if it's not equal 1, and then do another scanf every time. The good thing here is we don't need also the if condition for the sum, because if you think these two are on the same loop, but in fact they are executed in different iterations, right? So let's think about it. I do the sum in one iteration, so let's try to trace, right? So let's say initially the user inputs something as well. I want to show you this on writing, but okay, maybe I just do this here. Let's do some scanning, okay? Some kind of tracing. Assume initially the user inputs, well, initially X is 0, sum is 0, correct? And that's a good way for you to debug your code as well if you want to understand it. So you keep as if you're executing, as if you are a compiler. Then assume the user inputs something. So in line 21, the user will input X. Assume the user inputs X as 2 now, good. So the while loop will execute because X is 2, not 1. And then I will really do the sum. So in the first iteration, that's the first iteration, X is 2 initially, and then sum will equal 2 because I will add it up. And then I will scan another input from the user. Assume the user inputs something like 3. Now, let's say 1, right? Because 1 is really our corner case. What happens next? Once I read something from the user, I'm done with the current iteration. So I will go to iteration number 2. But for iteration number 2, X is 1. So I will not enter the loop and I'm done, right? So what I wanted to say is the sum will be guarded by this condition. So when the user inputs something here, if it's 1, it will not be added to the sum. So we don't need the if condition in this case, right? But we really need two Fs, like two scanfs, one at the very beginning and then one afterwards, right? Does this make sense? Good. So let's try to run this just to show you. So I input, like, what did we say? Like I input 2 in our tracing, and then I input 3, and then let's say I input 1. Well, the 1 is not added and just add 5, right? Good. So let me then ask another question. Is this one really needed? Can I just comment it out and then I have no change? Do I really need this one? That's the third example on the lecture 2 slides.
I don't think you need it.
Yeah, so can you wait a little bit why, Hakam? I don't need it?
Yeah, sure. So at first X is 0. And then you can ask the user for an input, but if you just remove it, it would be X is 0, and then it would go into the while loop, and then it would sum 0. So it wouldn't make a difference at the start, and then it would start asking the user for input.
Exactly. So, yeah. Thank you.
So
Hakam, please give me your name after the lecture. Okay.
Yeah, sure.
That's a good explanation. So basically, we really don't know this. This is redundant, and the main reason is, well, in the very first initial state, like first iteration, X is originally 0 and the sum is 0. Well, X is 0, so it's not 1. I will just add some 0 to 0, so still be 0. I didn't modify this, and then I read something from the user, right? So I really didn't change the logic of the code. So if I just rerun it, just like 2, 3, and then 1, well, it still be 5. Good. Does this make sense? Yeah, Saeed, that's exactly the case in your chat. Thank you also for answering. Okay, good. So now let's continue with the examples and see. Yeah, that's all. There isn't much. Okay, so now I will jump to the examples of lecture 3 if you don't have questions here. Okay. So let me switch sharing. And then I say window, this one. Okay, so in this example, what are we required to do? Read 15 floating point numbers input by the user, print them in reverse order. The last input number is printed first. Yeah, I have to store it. So basically, what is the difference here? Previously, we were really scanning inputs and operating on them on the fly, right? We really didn't need to do anything with the previous inputs because we just add them to the sum variable, right? So we read an input, we add it, and then we lose it because we kept overwriting X in our code on online GDB, right? In this example, the little change we introduce is, in fact, you need all your previous inputs. You need the history. So you need to keep all the inputs that are entered by the user, right? So the point is, well, if I want to keep them, I cannot keep overwriting X, right? So I need some sort of additional variables. Well, here there are 15 floating point numbers. Do I define 15 X's like X1 to X15? That's possible, right? But if you recall from Python, well, if you know that all of them are of the same type, floating point, and then you know the number, which is 15, well, it makes more sense instead of defining 15 different variables, is you just define an array of floating point type that has 15 entries, correct? Right? So this is what we are going to do right now. So if I just go a little bit of background before we jump into the code itself. So simply array in C is somehow, well, it's not exactly the same, but it's somehow the equivalent of a list in Python. If you are familiar with lists in Python, array is the closest to this. Again, C is a more strict language, so there are more rules for that. Uh, so and in fact, we have a separate lecture for more advanced concepts about array. But right now, I'm just introducing you to the general basics of the language, right? So if I want to use an array, well, an array can be used to represent a sequence of items, but all of them must be of the same type. That's very critical. You cannot have an array in C that has the first entry as int, but the second entry as float, the third one as string. That's not possible, right? And you can, the good thing about arrays is you can refer to individual elements of the array by using the index. So saying, if you have an array of type, let's say X, because here we used X as our variable, so we have array of X and it has 15 values, then X0 is your first element, then X1 is the second, etc., etc., right? Similar to any other variable in C, well, it must be defined or declared before using it. So that's normal. We already know this. And we will see how do we define an array in C now. Good. Yeah, similar to other variables as well. When the array is defined, the memory is allocated. Good. Okay. This is some example of how to define an array in C. Simply here, let me try to use the pen. First of all, I define the type, right? I'm going to convert some delay on the drawing. Yeah, good. Okay. So remember when we defined X just a single scalar variable, we just did int X. It's the type. That's the type. And this is the variable name. Correct? In array, well, it's exactly the same thing. That's the type. That's the name. But because it's an array, I also need the number of elements. And this is what you do in these square brackets, right? So here you are saying, I'm defining an array named data. All of the elements of the data array is of type int, and it has 10 elements. Good. If I want the type to be double instead, that's a different type. For floating point, that's the name of the array. It can be any valid name. It's up to you. And here it has 100 elements. Okay. This is how you declare an array. Then if you want to access, as we were saying, accessing a certain entry in the array, you just refer to it by the index, which is 4 here. So that's your array name. You put the square brackets again, and then the index of the element you want to access. Here we are assigning a value 34 to the array called my array element 4. Good. Does this make sense? What does double mean, Abdul Nasser? So double is a different type than int. Int means integer. Double means a floating point. So it can take decimal values, right? Non-integer values like fractional, right? And again, we have a separate lecture for all the types in C, but right now we are just introducing things a more casual way to write code. Okay, good. So given this kind of a little bit of background, let's try to write our program, right? So I will jump back to online GDB, and let's see what we can do. So what was the question again? Reading 15 floating point numbers inputted by the user and then print them in a reverse order. Okay. So first of all, well, starting from the same logic, we used X here. First of all, we are not summing up, so we don't need the sum variable. But we used X as our single variable to add the sum to. Right now, we need to make this as an array. So let's say, and it's also floating point, correct? So they asked floating point, so this has to be double now, not int. And then I need 15 elements, so I just say 15. Okay, so here I'm defining an array of type double, named X, it can be named anything, and then it has 15 elements. Good. And then I want to ask the user to input 15, so I say please input 15 floating point numbers, and you will get them in reverse order. Okay, that's just a message for convenience. It has nothing to do with the functionality, but just to instruct the user to input something. A question now, given that we know I want to read specific number of inputs, which is 15, should I keep using while, or maybe it's just easier to switch to for? What do you think? While could still be possible, and in fact, if we have a time, we will use it. We'll write it both in while and for. But for makes more sense now, right? Because we have again a counter of iterations. So going back to the for logic, so I'd say for. Right now, we will get back the I that we just removed. Let's say I, and then maybe initialize it to 0, or it doesn't really matter. Then say I equals 0, I less than 15, because we have a specific variable. And then I plus plus, whoever was asking about this means just add 1. So it's accounting. So I plus plus means equal I, means I equal I plus 1. Okay, that's what it means. And then inside this loop, I want to read floating point from the user, right? And then add it to the questions, and then add it to, well, I know I want to reprint it in reverse order. So I want to store them first in the array. Good. So how to do this? Simply, well, scanf again. I'm reading something from the screen, so scanf. Right now, scanf is written to read a single scalar value, and it's an integer because that's the specifier D. If you remember from previous lecture, we went through some of the specifiers. Well, D was 1 for integers. There was F for floating point. If it's float, type float, single precision, but then this is double, so it can be double precision. So I just say LF, which means long float, right? So LF in, excuse me, LF in C as a specifier means I'm going to read a long float from the user, okay? And then right now, I no longer, can I just say and X? Well, no, right? Because X is not really a single value now. It's an array, it's a data structure. So I want to write this into a specific element, right? So each time I want to take my number from the user, input it in the specific place in the array, right? So going back here, well, if I just stop sharing here, I believe does this put me back to the sharing here? No. I just want you to visualize what I'm talking about. You just add new slide, and then maybe just do this. Okay, where is the pen? Okay, so we had 15 elements of the array, right? That's 0 to 14. Arrays in C start from index 0. Each time the user inputs something, I want to store it in the array. So the first time it inputs something, that's input 1 from the user, I want to store it here. And then input 2, I want to store it here, etc., 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 right? Because, well, I want to keep all the 15 and then reverse their order. Good. So how to do this? So going back to our code, I want each time to place the input to a certain element in the array, but this certain element is not fixed, right? Yes, Aiden, thank you. So it has to be really changed every time for the iteration. What keeps the iteration number here is really the I itself, right? So I would say just and xi. Initially, I is 0. That means the first input will go to x0. But then afterwards, in the second iteration, the second input will go to x1 because I will be 1, and then x2 until x14, correct? So now I stored all of them. I want to bring them in the reverse order. So after basically here at this line of the code, well, I stored all the 15 inputs in the array, right? So that's basically the first step of the code, right? So maybe if you want to really write a meaningful comment, so you'd say, well, that's step 1, or, well, read and store all the 15 inputs in the array. What would be the second step? I want to print them in the reverse order, right? So what to do? Well, I want to go through the array, but not from beginning, because if I print it from beginning, so maybe let's do it. So now print in reverse order. So if I just do it, let's say, well, first of all, I need to go through an array, so it has to be really a loop, right? If I just do exactly the same loop, maybe 15 is a long number. Maybe let's just keep it 5 to be able to run multiple times, okay? But it wouldn't really matter. Well, it's just basically really exactly the same problem, but with a different number, okay? Just giving it 5 to be able to run multiple times. So if I do this and then print, well, the array elements, so printf, and then again, I want to print a float, so I would say lf, and then if I just do x I, in that case, maybe afterwards I want a space, so that the next time get something. If I do this, I'm going to print it x0, x1, x2, so it's exactly in the same order, right? So this is not reversing it, right? So what to do then? Well, someone is saying, well, what can I do is I can start I from 4, and then I is larger than or equal to 0, because it's 4, 3, 2, 1, 0. And then instead of incrementing I decrement it, right? And then by doing this, the first time I print x4, the second one I print x3, etc., right? So let's try this out. There are so many suggestions. I see that on the chat. You really guys are suggesting multiple things, so that's good. And we will go through them now. Am I missing something? Yeah. So let's say I'm inputting, well, right now the message is 15, but we know it's just 5. So what I would input is, let's say input 1, 2, 3, 4, 5. Then, well, they printed like in reverse order, and they also printed to be floating point, even if I inputted like integers, because we know that we are expecting floating points, right? Good. So now let's go back to the suggestions. That's not the only way of doing it. So some of you are saying, well, let's comment this out as one possible solution. And let's say I want to write this printing in a different order. So what if I want to still keep it starting from 0? If I want to still have it starting from 0, I need some kind of logic that operates on I, because I on its own wouldn't work, right? So as you and the others are saying, well, instead of doing this, I know my last number is 4, so I can just say 4 minus I. In this case, if I is 0, 4 minus 0 is 4. So I'm really doing it. And then if I is 1, then it will already give me 4 minus 1 is 3, etc. etc. So it should do exactly the same thing, right? So just do run. Then I input 1.2, in this case 1.3, 1.4, 1.5, 1.6. Then you just get them in the reverse order. Okay. Why? Because, well, I did here some kind of expression. I didn't operate directly on the I, but rather I really wrote a mathematical expression that operates on I. Why this thing is good? Because I want to show you from here one important thing is that really the index of the array can be a mathematical expression, as far as it computes or it results in an integer variable, because the index has to be an integer. You cannot say, for example, I want to access element 1.5 in the array, right? So as far as this is an expression that evaluates to an integer variable, it should be good. Okay. Okay, LF is long floating point because I define this as double, right? If you did F, it works for float, which means single precision. We will cover these things in more detail. Okay, so let's see here if there are questions. I guess there were other suggestions as well. Let me see. Emma, does the first entry in an array go by the index 0? Yes. Yeah. Are there other questions? Find it hard a little bit to track questions because you guys have so many messages. Could we write X1? Yeah, that's, I guess, in the first loop. Yeah, that's okay, good. That's also another suggestion that let's see. So first of all, the way I store my elements in the array, really it's up to me because that's something that is not visible. What did I do here? So it's up to me because that's not something visible to the user. So some of the suggestions here say, well, why you store them in this order? You can really say, well, I can start from the reverse order similar to the logic we had before, and then x is larger than or equal 0, and then I minus minus, and then I would just really store the first element in the last place, etc., 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 right? And then when I go to the print, I can just really print it. Let me just keep this and have another one. If I already stored the elements from the beginning in the reverse order, I can just go now in the normal order, and instead of having any expression, it will be just I, right? Why? Because going back to this figure, instead of doing what we have here, which is storing them in the increasing order, I'm doing something different. In this last code that we have been writing, I'm really storing them. Input 1, maybe I just use a different color. Input 1 now will go to the last element. Input 2 will go to the last minus 1 element, etc., etc., right? So I'm storing them originally in the reverse order. So when I print them, I can just easily print them in the normal order. So it's up to you. You can really store them in reverse order, and then you go, when you print, you go from the beginning, or you store them in the normal order and then you go from the end of the array. Both will give you exactly the same thing. Good. Matthew, do for loops in C always take 3 arguments? Yes, they have to take 3 arguments, but sometimes they can be empty. Like, and again, we will go into the for loop in some other lecture in a detail. But I said this also last lecture. So, well, we don't need this visualization anymore. So maybe I can switch to the code. Share and do that. So as I said last lecture, in fact, for example, if you don't want to increment I here, you can do this. And you can just say, well, I plus plus. That's really completely equivalent. Still 4 takes 3 arguments, but the last one is empty. You don't need an increment condition, right? It's up to you, right? So that's the, and we will play around with loops later on in detail, but that's possible in C, okay? But at the end, those are still 3 arguments. Some of them are empty. For example, you might not need a condition, or you put the condition inside. That's also possible, okay? Good. So let's see if we have other examples. We went through all of this. Maybe one good exercise is try at home as part of this lecture study is if you want to implement exactly the same logic using while loops instead. Okay, this might be a good exercise to try on your own and maybe ask during office hours if you got questions. Good. So I will jump quickly to the second example, and then I will take questions to make sure we have enough time to cover the second example. So in the second example, well, I need again to switch screen. So I want to ask the user to input a sequence of 20 integers, store them in an array, determine if the sequence sorted in non-decreasing order. Okay, so this is a little bit more complex. Previously, what I have done is I stored all the elements in an array, print in a reverse order without really doing anything related to the inputs themselves. Right now, I want to do a further check. So I want to take 20 integers. I will store them in the array. We have done this already, so this should be fine. But the main thing is I want to determine if the sequence is sorted in a non-decreasing order, right? So to think in these problems, you really, before even start coding, and that's a very important practice from the first lecture, define your own problem, define your algorithm before coding it. This is the correct software engineering flow, not just jump directly into coding and start really like trying here and there. This wouldn't work. Think carefully first, maybe even have some sort of pseudocode or flowchart in your mind, or scratch it as you will do right now. Then afterwards, you can go ahead and write your code, right? So if I want to define this problem as an algorithm, what do I want to do? I would say, first of all, I want to read input from the user. I loop through an array. Well, after I take the inputs, that's the first step. The second step would be loop through the array to check if the current item is less than or equal to the next item. If that's the case, then I want it to be in a non-decreasing order, which means all the time the next item should be at the very least equal or larger than the current item. So if that's satisfied, then it's sorted, so I can continue. If it's not satisfied at any single moment, that means I broke the condition, which is, well, the array is not in a non-decreasing order. I can just break and flag something, right? So what does it say? Check its non-decreasing order, and then maybe you will print a message to the user, right? So let's quickly try to write this down. But even before writing this down, maybe something I can try to do is, let's say, have a new slide. And then let's do the following. So first of all, if I'm writing a flow chart for this, I would say, well, read 20 inputs and store an array. Well, that's the first step. We have done it straightforward, no problem. But right now, here comes the meat part of the algorithm. I want to go through this array and check the sorting order from like the non-decreasing order. So I should have some sort of a loop of iteration. And so I have a counter that's starting from I equals 0. And then my font is very large, so it will not fit in here. But let's see. As far as I is less than 20, so I'm still within my array boundary, I need to do another check. Is the array I is less than or equal to array I plus 1? Oh, that's bad. We put it in this way. If array I less than or equal array I plus 1, then you are good, right? So you have no problem. You can increase I, then jump to here. This is really the flowchart representation of a loop. That's if yes. If no, well, I broke my condition. So I flag something like print something on the screen to the user, well, you are not in a non-decreasing order, right? So this is how you just think about a problem. Is if you are ever confused, especially for lab questions that might become very involved. This is a very simple example, but when questions become a little bit involved, maybe sort your mind first. Okay. After doing, is there any question about this logic before we code it? Right. I will just take a couple of minutes and then we should be done. Okay. So jumping back here. Well, I'm still defining my array. This time it's an int, which says like it's 20, but it can be of any size. Let's keep it 5 for experimentation. I have a loop. Please input 5 integers, their order. And then here, well, I don't really need the thing in reverse order. So I say I, then I is less than 5, and then I plus plus. And then I keep reading. In this case, I'm reading decimals, so it should be D, like reading integers, I mean. After storing this in the array, here comes, well, 5. This is the first block in our flow chart. And then here comes the second stage, which is checking the array logic. So I will do for I equals 0, I less than 5, and then I plus plus. And then I want to do some check. How to check if the current element is larger than the second element? I would just say simply xi less than or equal xi plus 1. If that's the case, then you are good, right? Otherwise, you should break. So this is your satisfying condition. But if xi is larger than xi plus 1, well, I have a problem, right? So what should I do? I can just simply break the loop completely and say, well, here, I want really to keep a flag. So I would say before breaking, I would say flag equal 1. Oh, one big problem, I didn't define flag. So I would just say here int I and flag. I'm using this flag to indicate whether I broke my condition or not. If flag is equal 0 initially, if it keeps 0, that means all the items are sorted. If flag at any certain point is set to 1, that means this condition is satisfied, which means, oh, this is not non-decreasing order, right? Because xi plus 1 is less than xi. That's a decreasing order. Good. So here outside the loop, I need to print a message stating that, well, whether you broke your condition or not. What tells me whether I broke my condition or not is the flag variable. So let's say if flag equal 1, that's checking equality in C, and we have done it previously for the odd and even checking condition. If that's the case, that means you broke your condition. So I'll print a message, say, oh, this is non-decreasing order. And then it says here, else, if it's else, well, flag is 0, then I will just print good. This is, oh, this is not non-decreasing order. This is non-decreasing order. Okay. So I know that I'm going too quick, but maybe we revisit the example. I just wanted to give you some hint to look into the slides. So let's try to run this. I hope I don't have any problems. So let's say I input something that is a non-decreasing order. So I input 1, 2, 3, 4, 5. Good. It is non-decreasing order because all the time it increases, right? Let's say I input something that is like 5, and then 2, and 1, 4, and then 3. Oh, this non-decreasing order makes sense. Let's try something that is on a tie, like it's basically on like things that are equivalent. Then let's say I input then 6, 7, then 8. Good. This is non-decreasing order. Why? Because non-decreasing means the next item is not less than. If it's equal, fine, because our checking condition here is only for larger, right? So it means if it's less or equal, as we wrote in our flow chart, we are good, right? Well, that's really 4 minutes over. So what I can do is I will stop here. Next time we'll play around with this example, but hopefully you have some sort of a start to look into the example yourself and try to code it at home. So I will stop here. Thanks everyone, and then next lecture we will also revisit this. I'm staying to take questions if there are any for a few minutes. Okay, thanks everyone, and I'll talk to you tomorrow. Questions? Do for loops in C. Yeah, I already answered this, Timothy. When I try to run my code, why does it say nothing to build? Nothing to build. I guess you have to pick the, like, I guess you're trying Eclipse, so you should, well, that's a problem that I would say requires sharing screen, but at the very least try to highlight the project like on the left pane before choosing project build project. Okay, should I less than 19 send the last I would go out of bounds side? Exactly, that's this should be the correct thing. So here, in fact, it didn't show us any problem, but you are definitely correct in the sense that I'm doing I plus 1. If my array size is 5, that means the last element is 4, not 5. So if it's 4 plus 1, 5, that's really going out of boundary. But I didn't go through this today, but you are definitely correct. This really should be 4, not 5, right? Because I'm checking the one with the next one. The last one wouldn't be checked with anyone else, right? Ryan, my code will only print after I input. Is it? Yeah, Eclipse. We mentioned this point at the beginning of the lecture. Eclipse in Windows has some sort of buffering or console problem for printf and scanf. It's not the best mean to use it. There are some workarounds. Something you can try is fflush std out function. Put this after your first printf. This might solve the problem, but generally printf and scanf not very well handled in Eclipse Windows, especially. And we really don't need it for the lab. So I would say if you want to experiment with this, maybe online GDB is a good option. In labs, you don't do any printfs or scanfs, so we should be fine. For fflush standard out, well, it worked for me without includes, but I guess std lib is also can be included for this one if you would like. But try it without includes, it should work. But we do this without the flag, for example, putting the printf before the break. Yes, you can. But then the point is, how do you know? Well, if I only have a single printf, which is you broke your condition, it should be fine. But what if after I finish the loop and I want to print that this is good? How to know whether, how to keep the information from the loop to outside the loop that really I never block my condition? That's the point about the flag, right? But Ethan, you can try it out, and there might be a solution for, like, there are, again, for the same problem, same algorithm, there can be so many solutions. So we can start with this next lecture tomorrow, and we'll go through different options as well. Good. Are there any other questions? Shara, for lab 0, are we expected to just add one test case? Yes. What you are asked to do in lab 0 is add, I guess, was it 1 or 2 in lab 0? I don't recall, but whatever you are asked in the lab document, this is really the requirement, right? So your contract for getting the grades for the lab is really the lab document, right? Unless I provide you with further instructions. So follow whatever there in the document. Good. Other questions?
Hi, Professor.
Yeah.
Did you still want my name from earlier?
Yes, please, Hakam. What about the following? Can you please send an email to the main TA, like Mohammed Abu Leila, like his email address in the first lecture, and put in the title conventional SH4, and then put also bonus mark, right? This way we can really keep track very easily about this. So once you just write an email to the main TA, this should be kept track of, yeah, because at the end of the semester, I really put all of this together and then add the bonus marks for everyone.
All
Thank
right,
you
cool.
so much.
Thank you,
Yeah,
Professor.
thank you. Howman, why do we initialize I before the loop? Howman, that's a good question. In modern C standards, you mean define, not initialize, right? Because you really don't need to initialize. Here, I didn't initialize it. I just defined, declared it. So if you mean declare, in modern C standards, you can do something like this, int I. So you declare I inside the for loop header. But in C89, that's really a warning or an error even for some compilers. So just to stick to any code that works for any C standard, what I do is I declare the counter before the loop and I initialize it inside the loop, right? Aisha, if our workflow in GitHub is successful, does this mean our code is correct? So Aisha, I guess as I answered this question at the beginning of the lecture, the workflow in GitHub, this green check mark, only gives you a confidence that whatever test cases you have in your repository are passing. So this should be good overall. But for example, if you didn't add the additional test case you are asked to do, you might still get really the green mark because you are passing our own test cases that we gave you, right? But you might lose marks because you didn't add your own test case. So it tells you you are good, but you are good for the test cases that are in your repository. If you didn't add additional, well, this is something you need to consider. Will the test cases that we are tested on Lab 0 include decimal or strings? No, it's only for int types because the function is written for int, right? But they can include negative and positive numbers. Why is the second if statement directly under the for loop even if flag is 1 is not in line with it? I'm not sure I'm getting the question, Turin, but put in mind that C, if you are talking about alignment, C is not doing loops and conditions in like similar to Python. Python has this tab stuff that aligns the conditions, right? Here, everything is with the brackets, right? So here we have an open curly bracket ending one, which means this is the F block. This one matches this one. This is the for block, right? I'm not sure if this answers your question. To be honest, I'm not very sure I'm getting it.
Sorry. So, cause like, you know how like in the first if statement you put like flag equals 1, doesn't matter that the second if statement like there's another flag, but like are they related? Cause
Oh,
like
this one.
yeah.
Oh, okay. So you're talking about the logic. Okay, so this one is checking whether you are meeting your condition or not. Here you are breaking the condition because you are not in an undecreasing order. Here you set the flag to be 1. So you are really overwriting the flag from 0 to 1. We go outside the loop. This if statement is different. This if statement is checking because this is not really assigning, this checking equality. So it says, is the flag 1? If it's 1, it means really you went inside this if condition, right? Which means you really is not in an undecreasing order. So you bend this. So what we do in this logic is we say, inside the loop, I'm going through the elements one by one, check if my condition is met. If it's met, I'm setting the flag to 1, which means there was an element, for example, here. This I will never visit the if condition here, basically, right? Because all the elements are really smaller than or equal to their next ones, right? If you think, for example, in this exam, like in this input sample, the first one was 5, the second one was 5. So x0 is not larger than x1, right? So this if condition is not satisfied. I will never set the flag to 1. 5 also is not larger than 6. 6 also is not larger than 7. 7 is not larger than 8. So I will never visit this if block because all the time this condition is not satisfied. What does it mean? It means the flag will never be 1. So it will stay to its original value, which is 0, right? So if I go to the outside the loop, here is where I check whether really I throughout the array, whether I encounter the flag of 1 or not. In our example here, we never visited this. So flag will never was like it's never assigned to 1. That means this condition is not satisfied. I'm in the else, which means I'm good. Does this explain to you the logic?
Yes, because I thought that like the if and else statement were in the for loop, but like it's
I see. Okay.
Yeah.
So we do this outside the loop to check what did we find inside checking the array, right? So the loop goes through all the array elements. I keep track. Once I'm done, right now I want to print something to the user based on my flag, right?
Okay. Thank you.
Brian, where should I go for help with Eclipse? Well, office hours 10:30 to 2:30 every day. Currently, we have office hours going through. You already have invitations to all the office hours. They should be in your calendar. They are also part of this team. So just go there, right? and we have been running these office hours for at least more than a week right now, and I drop in these office hours myself as well, and your colleagues come there for help. This is where you should go. Also, you have your lab session. I don't know, Ryan, what lab session you are in, but lab sessions are also for help, right? Ahmed, why is it when we switch the two lines I marked here, line 1 and line 2, the program worked and didn't add the 1? Yeah, okay, because simply the scanf is done in one iteration, but the sum is done in the second iteration. So the sum is guarded by the condition of the while loop. Assume, for example, you inputted 1, right? In one of the scanfs. You don't directly go ahead and update the sum. You go first, according to your logic, right? You go first, check the while condition. In this case, the while condition will not be satisfied, which means the sum will not be executed. So try to trace it, right? Try to basically do similar to what we have done in this lecture, do a tracing by examples, and you will see it out. Do we get participation marks? Yes, Trenu, you get, as I have done this lecture in the previous lectures, we have those bonus grades where I say, well, you answer a question that I guess would worth a bonus mark. Sometimes I will let you know that, well, this worth a bonus mark if you answer, and then I take the names of those students, keep track of it, usually by emailing the main TA after the lecture if I asked you to email him, and then CC me as well. And then those will be bonus marks for participation. Good. But participation grades are only bonus, not part of the course. So you will not be losing them if you don't participate, but you are highly encouraged to get those bonus grades to basically fill in any gaps you might get in labs or midterm or final. Good. Are there any other questions? Okay, so thanks everyone. I will see you tomorrow. I might also see you today, either in the lab or the office hours, the T office hours. If you still have questions again with Eclipse, please drop it in these, and you'll be able to share a screen, and we can help you with that. Good. Thanks everyone, and I'll talk to you tomorrow. Bye bye.